Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T, and in this video I have the solutions for the first two problems in your integration by partial fractions assignment number 1. So check your work and see how you did. So our first problem is shown here, and we need to first factor our denominator. So our denominator will factor into x plus 3 and x minus 2. And to facilitate this integration, our first step is going to be to do the partial fraction decomposition. So if you remember from the tutorial video, we start with our fraction with the factor denominator, and then for each unique factor in the denominator, we're going to split this up into separate fractions, or the partial fractions. And there will be some constant in the numerator that we have to figure out what that is. So, as we talked about in the tutorial video, this is a rational equation, and to solve a rational equation, we're going to multiply every term by our least common denominator, which is x plus 3 times x minus 2. So that's an x minus 2 there. Over 1. So again, we're multiplying times all three things. When I multiply this fraction by that, both denominators cancel out, and we're just left with 5. Here, my x plus 3 cancels out, so I'm left with a times x minus 2 and b times x plus 3. Now remember, this equation is true for all values of x, so we can intelligently select some values of x to make one or the other of these letters disappear. So let's start out, let's find the value of a, so we want to make b disappear. So if I put negative 3 in here, I'm going to get 0. So let's start out choosing x equals negative 3. So we substitute all the way across. So we get 5 equals a times negative 3 minus 2 plus b, and that's going to be times 0, so that's disappearing. So now we have, if we simplify, 5 equals, that's negative 5a, and divide by the negative 5, and we get a equals negative 1. Now we need to pick a different value of x so that we can find the value of b. So this time we want the a to disappear, so I'm going to pick x equals 2 and repeat that same process. So if I put 2 in here, I've got 0 times a, which is 0, that disappears, and then we have b times 2 plus 3, or we have 5 equals 5b, or b equals 1. So we're going to now replace our original integrand with, let me just change color. So this part here was our partial fraction decomposition. It has nothing to do with integration, but that now creates a format of this problem where we can do the integration. So we're going to split this up into the integral of this and that. Since they're sums, we can integrate separately. So the first fraction is a, which is negative 1 over 3. So I'm going to bring the negative 1 out front. So again, the negative 1 for the a is on top, but I'm bringing my constant out front of the integral. So remember, we're integrating that, and we're integrating that, so I can bring these constants out front. And then plus, now we have the second fraction, b here, we have a 1, and then 1 over x minus 2. Now both of these are, we have 1 over, we have u prime over u, and u is x plus 3, so u prime is 1, what we have, same here. So we can just apply our ln rule. So now I have negative ln of x plus 3 plus ln of x minus 2. And we could potentially leave the answer like that, but I can condense using my logarithm properties. So the subtraction, this will go in the denominator, so we can condense to a single logarithm of x minus 2 over x plus 3. And that will be our final answer. So that's the answer for 2A. I hope you were successful in getting that answer, working the problem yourself. So let's look at the second problem. So if we factor our denominator here, I need a 2x plus something and an x plus or minus something, and I need these worked out so that when I FOIL I get my middle term. So I think I need a -1 here and a +1, so that's going to give me 2x minus x. That works. So now let's set up for our partial fraction decomposition. Again, we are going to multiply every one of these terms by our least common denominator, which is the original denominator. So here I'm left with, when I cancel out both factors, I get 5 minus x. And here the 2x minus 1 cancels, and I'm left with an x plus 1. And the x plus 1 cancels, and I'm left with that. And again, our next step now is to intelligently pick values of x to get one of the letters to disappear. It's going to be easiest to get the a to disappear by picking x equals -1. So I have 5 minus -1 equals a. Now that's going to be -1 plus 1 is 0. 0 times a is 0, so I'm not going to show that. So this is -3, so we've got, this is plus, so we've got 6 equals -3b, or b equals -2. Now, to get the b to disappear, I'd have to pick the fraction 1/2, or my other choice is to pick a friendlier version of x, which I'm going to pick 0, but then we can also substitute in -2 for the b. So if we use this substitution, I've got 5 minus 0 is 5. And I put 0 in for the x, so I have a. Now for the b, I have to put my -2 in. And then in here, I'm putting 0, so I have 2 times 0 is 0 minus 1, so times -1. So I get 5 equals a plus 2, or a equals -3. So again, that was our partial fraction decomposition. So now let's break our integral into 2 integrals using our 2 partial fractions. And again, I'm going to move the a out front. So a is -3. So I have -3 integral of 1 over 2x minus 1 dx. And my b is -2, so I'll bring that out front. Now we have to use the simplified version of integration by substitution here. My u is 2x minus 1, so I need u prime to be 2. So we need a 2 here, and to put a 2 there, remember we have to divide out here. So now I have -3/2 ln of 2x minus 1, and then minus 2 times the, I'm sorry, I messed up over here. This is a +3. So this is now plus, and that's plus. So hopefully you caught that mistake earlier. Ln of x plus 1. And again, if I condense, now this would be, let's do it in 2 steps. If I bring this in, it's going to become the exponent here. And 3/2 is the same as the square root of 2x minus 1 cubed. And this is going to be the ln of x plus 1 squared. And now we do the subtraction, which turns into a division. And we can write our final condensed answer like this. That's cubed. That's over x plus 1 squared. And again, we need our absolute value. And now we're done. So this one was a slight bit trickier, but still fairly straightforward. And I hope you had success. I'm having fun at the wedding, and I'll see you next week.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you